Alright, again, simplifying some roots. When we're trying to take the square root of 25x to the fourth, we take the square root of 25, which is 5. And then for the square root of x to the fourth, we're looking for groups of 2, because this is a square root. So how many groups of 2 are in x to the fourth? Well, there's 2 of them. For the fourth root of x to the fourth, y to the 12th, again, we're going to look for groups of, this time, 4. In x to the fourth, there's only one group of 4. In y to the 12th, there are 3 groups of 4. For the cubed root of negative 8, x to the 6th, y to the 21st. First take the cubed root of 8, which is negative 2. Then look for groups of 3, because we're at the third root. In x to the 6th, there are 2 groups of 3. And in y to the 21st, there are 7 groups of 3. For the 7th root, we're going to look for groups of 7. So a to the 7th has 1 group of 7. B to the 77th has 11 groups of 7. And C to the 70th has 10 groups of 7. Of course, with these powers of 1, we don't have to write anything. We can just leave it as A. Lastly, for part E, again, another square root. So square root of 36 is 6, and then look for groups of 2. X squared has 1 group of 2. W to the 10th has 5 groups of 2. So we don't have to write the first power. I want to go over these 3 problems as well, because I realize I don't have them on the review, but they're on the test in one form or another. With the square root of 49 n to the 5th, the square root of 49 is going to be 7. And then we have to take the square root of n to the 5th. And we're looking for groups of 2. Now, there aren't an even number of groups of 2. But when I'm looking at the square root of n to the 5th, n to the 5th is n to the 4th times n. And with n to the 4th, there are 2 groups of 2 in n to the 4th. So that will take care of this one factor. Now, what we're left with is still the square root of n. When we're looking at the square root of 32, that's not a nice even number, so we break it up into its perfect square factors, 16 and 2. Now we can take the square root of 16, which is 4, but the square root of 2 stays underneath as the square root of 2. And then one more, the cubed root of 40m to the 7th. That's going to be a combination of those last 2 problems. The cubed root of 40 isn't a nice even number, but 40 is 8 times 5. M to the 7th doesn't have a nice even number of groups of 3, so we'll break that up into m to the 6th times m to the 1st. Now we can take the cubed root of every piece. The cubed root of 8 is 2. The cubed root of 5 is the cubed root of 5. The cubed root of m to the 6th, well, that has 2 groups of 3 in it. And the cubed root of m is going to be the cubed root of m. Take the 2 pieces that are not under the square root and write them first. And those other 2 pieces, put them under 1 cubed root, 5m. Then this is a simplified version of the cubed root of 40m to the 7th.